Hello, everyone, and welcome to Innovation Coffee brought to you by ARM. I'm your host, Robert Wolf, and today we have a very exciting episode for you. In fact, a very exciting announcement to bring to you today. Please pardon me if I'm a little bit rusty, as you may know, for those of you who show up to this live stream on the weekly basis. We haven't been doing this for a few weeks. The holidays are over. So, for all of you watching, Happy New Year. I hope you had a wonderful holiday season with you, your family, and your friends. On behalf of me, on behalf of ARM, hope you had a wonderful time. And now it's time to get back to work. Although I don't look at this show, or at least I don't consider this show and doing this stuff as work. It's just so much fun, right? So let's get to the episode at hand. We have some really cool stuff to go over today. In fact, it's a first for me. It's a first, I think, for us here at ARM to launch a brand new program or a brand new part of a program that exists here at ARM called Works on ARM. And for those of you who are not already familiar with Works on ARM, it's a program that we have hosted here at ARM for a while now. I think it's been several years. And what we've traditionally done is provided software developers in the open source space a means to check out or request free hardware subsidized by ARM in the server space. Now, traditionally, this has been in the form of Equinix bare metal servers. There is Oracle on there. There's AWS on there. There's OSU OSL, which is a university open source lab. You can go in there and you can request hardware for your open source projects. You can go get this hardware accessible to you and your teams. Use that hardware for an extended period of time, all again subsidized by ARM. Now, why is today special? Why is today going to be so much fun? Because we're announcing a new addition to this program. This new addition brings you edge access. So, sorry, again, Rusty. This brings you edge access to edge devices, right? So, I'm going to bring one of our guests on here. Our guest, David Tishler, is one of our ARM innovators. And we're going to talk to you all about why this is so cool, why this is so important, and why it's important for you developers to get access to this edge hardware. So let's just kind of skip right ahead. Let's bring David on. And while we bring David on, I want to remind everyone, if you're watching, please make sure if you like the video, if you like this live stream, hit that like button right there. It definitely helps us out. And if you like this show, you can check us out every week, Thursday at 5 p.m. UTC, right here on the ARM Software Developer YouTube channel. You can get your notifications by subscribing to the channel and then setting those notifications up. All right, David Tishler, welcome. How are you, sir?
I'm good. How are you?
Good. How did I do on that
You're
intro?
Over here? You're over this way? This way.
Hey, hello. Yeah. Yeah, welcome. You've been on the show many times, so you already know that the spiel. You have coffee on you?
You know I do.
All right. Well, cheers to you, my friend. I'm doing something different. I got a little I didn't become a giant. This is actually a small cup. It's an espresso cup. It's not an ad, but I recently got an Nespresso machine and it's amazing. So I'm cheers, David.
Well, mine is giant. Yours is that little mini tiny thing. But I don't know. You were telling me before the show that those are pretty awesome. I think I might have to go check those out. So if you want to send me an Amazon referral link or something, I think I'm going to be looking into one of those.
I'll let you know. Yeah, for sure. Cool. So, David, like I said, you've been on the show a lot of times, but there might be one or two people out there watching who don't know who you are. So, who are you? What do you do?
Awesome.
Tell us a little about yourself.
All right. Well, thank you, Robert. Before I do that, I'm a little upset, though, because I thought we were going to do Innovation Cribs. I was ready to take you on a tour around this data center that I'm in today. But we'll get to that in a moment. So I'm David Tishler. I am an ARM innovator, which means that I get to build cool projects using ARM technology in a variety of capacities. Over the years, I have spoken at ARM TechCon, now known as Dev Summit. We've built projects that show off IoT to edge to cloud server capability, all running on ARM. You and I have done off-grid, solar-powered 96 boards, remote computing. I call it devices. It looked like a briefcase. It looked like a bomb.
I have that in my. I
don't know how you got
I
through
have it right
security with that. We've done all kinds of things, and this one that we're announcing today is super exciting. We'll get into in a few minutes, but I'm all about ARM ecosystem evangelism, and I got the memo on the shirt to wear today.
Look at that! Yeah. All the innovators. I try to get all of the innovators some of these shirts. That's awesome. Thanks for wearing that, David.
Yeah.
So real quick, I noticed my mom's in the chat. I don't get it often a chance to say hi to my mom. Hi, Mom.
Hi, Tammy.
That's her right there. Tammy,
That's her right there. Hi, Tammy.
Hi, Mom. Hope you're doing well. So David, let's take it the next step here, right? Because we are going to talk and we're going to say all these names and things, and I don't want people to not know what they are. Mini Nodes. Mini Nodes is a company that you founded, that you run. Tell us a little bit about Mini Nodes.
Mini Nodes has actually been around for quite a while now. Rachel and I were chatting while you were making your Nespresso. I think it's been about 5 or 6 years since I founded Mini Nodes. And Mini Nodes has been all about just bleeding edge ARM innovation. It's a little bit of a services company is really where the public facing focus has been, where anyone can come and essentially spin up or rent a Raspberry Pi or Jetson Nano. And I've hosted them for years and years, but honestly, most of the work is really in consulting or evangelism or just using the brand as a platform for the things that I'm interested in. So yeah, the public facing bit of it, people might know, I can go rent a Raspberry Pi. Okay, well, that's fine. I mean, you can also buy a Raspberry Pi and put it on your desk, if you need it hosted in a data center and, available 24/7 or whatever. Well, then, yeah, I'm your guy. But a lot of, and there's other providers that do that as well. But a lot of the focus has really been on engineering and just innovative kind of pushing the envelope of what ARM compute can do. I have not really dabbled into, ARM chips or in cell phones. I don't know the first thing about cell phones. I tend to gravitate towards compute and traditional cloud native infrastructure, but running on ARM. So I hope that's a good background.
That is a good background. That explains it. Yeah. So I mean, like David said, traditionally, right? You can just go buy a Raspberry Pi, or if you don't need to buy the Raspberry Pi, you could just go to a company like Mini Nodes and request one and pay a certain amount of money. Yeah. Now, it goes beyond Raspberry Pi, right? Because there are so many, unlike the server space where you have a select few people who are running these huge servers. In the edge space, you have dozens and dozens, if anything, maybe hundreds of single board computers, all running ARM, and to fit every developer's individual use cases or vertical markets that they're trying to tackle. And in a lot of cases, some of these boards, and we've learned throughout the COVID experience that some of these boards may right now not be very accessible, or even traditionally, even before COVID, not very accessible. In fact, lead times on some of these boards, depending on how many are made or how many people want them at the very beginning when they're first coming out. We don't know how many people are going to be ordering these things. And so, sometimes they might make a batch and then those get sold very quickly and it was unexpected. And the next thing you know, the next batch might not be available for 6 months down the line. So this happens very frequently. And then COVID brought in a whole new plethora of problems where you're looking at supply chain issues and shipping congestion. So, this idea kind of spawned from the COVID situation, but it extends further from that, right? And it really does address some of the initial days where, you had these long lead times and high cost items. high cost devices where developers need access to these things, but they can't get it. And so this is the solution that we're trying to crack here with this new, and I'm going to start right now, new community hardware developer or the community hardware program. Yeah. And this is a partnership that we have formed with Mininodes, ARM and Mininodes, to offer developers subsidized, or in your case, free access to a bunch of different ARM-based edge devices. Now, the process, we're going to go over the process and what kind of stuff you're going to have access to, the cool stuff that we've built and open sourced available for everyone to go. We have a whole list of things that we're going to go over here, make sure that we cover it all. But I guess to kickstart it all, we did share a link right here. You can go to the Mininodes Community Hardware Program landing page, mininodes.com/all that stuff. We'll also share.
Need to shorten that.
We'll also share it in the chat too, so you can just click it probably. But I guess the long story short here is that you can go now, literally at this very moment. You can go click this link. There are going to be several links that kind of take you to the same place. But you can go click that link and you can go request hardware now. Now, to start this off, I kind of want to give a little bit more of a explanation or reason why this is important, right? So we've been talking about Raspberry Pis, right? There's also NVIDIA Jets and Nanos. These are two kind of very common single board computers or edge devices that developers need to get their hands on. These are more readily available devices. You can go order those very easily. One of the really cool things about this program is, of course, ARM has a very robust partner ecosystem, and a lot of our partners are building very interesting devices for developers out there. Now, what we plan on doing with this program is making sure that we have as many of these devices as possible in this lab or in these racks. Okay. So this means that it's very possible in the near future and moving on through this program that you can go check out the request form. And one day you might see a list of 5 boards or 10 boards, and then check back a week later, and there might be a board in there that you didn't even know was available yet. Some early access hardware that you might really be interested in using. Also some devices that may not be so readily available to you either in your region or in general around the world because of supply issues or just because they ran out in that batch. And so we hope to hold a bunch of these boards. And in fact, later on in the show, I'm going to give you a sneak peek. I'm going to do an unboxing of an example of one of these boards. They're so hard to get. This is the RB.
I've been trying for 2 years.
Yeah, they're almost impossible to get. This is the RB5 96 boards. There will be a couple of these in these racks, right? So this is a very powerful Snapdragon chipset from Qualcomm, and we're going to have a couple of those in the rack for people to go check out. So David, let's talk about, first of all, I guess, where are you? Because this isn't your usual background. Because
this is not my home office. No, I am at the Flexential Deer Valley Data Center in Phoenix, which is where we have leased out a colo rack, a standard, for those of you that are familiar with data centers, standard 42U metal cabinet rack. Dual redundant power, dual redundant internet, dual redundant firewalls coming into the rack. And then from there, 4 or 5 switches. I can't even remember now. And then we have 3 4U chassis that would normally be like storage network devices or big GPU servers, but instead we've gutted them out, left just the chassis, the rails to pop into the rack, and opened up the back to bring in Ethernet and power. And inside of those chassis are where we've housed all of these boards. And we can show off in just a moment. I see you've got some behind you, but I'm in the conference room at the data center because for those of you, again, who have some data center experience know it is loud inside of the server room. So it is a traditional, it's actually a beautiful facility. It's only about 2 or 3 years old. I remember when it was built. It's just right down the road from where I live. And it is a state-of-the-art data center, and it sounds like a jet engine inside of the server room. So I was just in there about 30 minutes ago, and I was thinking, well, it'd be nice to be able to show off the rack and whatnot, but it's impossible. We can't do a live stream.
We have pictures.
Yeah. So here I am in the conference room. The servers are about 50 feet that way.
So David, real quick, I want to start this. I want to start this off, and we will do a little quote unquote innovation coffee cribs, because I know you have some stuff on your desk here. But I want to start this off with kind of like the origin story. I know I talked a little bit about kind of like the reasons why, but this idea came to us. Excuse me. Because of one of our other ARM innovators, Ajit Raina. And you may be familiar with him, maybe not, on Twitter. But Ajit Raina came to me, I think this was a year and a half ago, because he needed access to 4 NVIDIA Jetson nanoboards, right, David? I think it was 4.
It is 4, and I still have them running. He has access. Yes, he's a Docker captain. He needed to do... I think he's actually might be employed by Redis, if I remember correctly, but he needed to do some development work, but he couldn't get a hold of Jetsons in India, where he's located.
Yeah, and the first thing that I said, I was like, okay, well, you're an ARM innovator, you know, you're developing some really cool stuff, and I'm trying to think, like, how can I send you 4 NVIDIA Jetson Nanos? And the first thing he said is, oh no, I don't need them on hand. Like, can you just plug 4 of them in and let me tap into them? And I'm just thinking, I'm like, well, shoot, you know, I guess I could, because I have some NVIDIA Jetson Nanos here at my house. But who better to talk to about this than David Tishler? Because he literally runs a company that specializes in hosting these edge devices, these single board computers. And so then David comes into the picture, right? And this is a long time coming, but here we go. David says, yeah, I can do that. That's easy. Send me the Jetsons. Very easy for me to ship to Arizona, Phoenix. Yeah. And then he gets them all hooked up and set up. And so then we start exploring, well, you know, it seems that this is something developers need and want, right? And so, you know, I poke around, and it turns out that people actually are interested in this, and not only just, again, the easy accessible
Who knew?
boards. Who knew? Yeah. Not only the boards that are easy to access, but even more so when we get to boards that are a little bit more difficult to access. And so I work with David. We come up with this kind of scheme, this big plan. He draws up a proposal. I then bring in a friend of mine named Gabriel Peterson. And I do want to just kind of make sure I share his LinkedIn here, because the guy is amazing. He comes in the 11th hour and says, yeah, I can. He's very, very experienced when it comes to 3D design. And he literally builds all of these racks and components from scratch. Now, one of the biggest things we wanted to address here was the universal slide, right? Because David, I think you were saying, like, and I've searched the internet too, it's very hard. There are already these types of racks for just Raspberry Pis or just Nanos, but we wanted something that was universal. And so he comes in here and he designs these little sliders. And not only that, David, I guess maybe you can explain the difficulties here, right? Because it was not only the universal racks, but also the ability to swap out a single board, right? Because that was also a difficulty.
Yeah, so you can see I have on the desk in front of me, let me see, that is a pair of Raspberry Pis. The one on the right, let me pull this a little closer. This is from Solid Run. This is another great partner. And I'll talk about the hardware in just a moment. But the point that I wanted to make here is that you can see all of these boards. That's 96 boards form factor, and that's an NVIDIA Jetson Xavier NX form factor. The point, though, is that all the various boards all mount onto these plates. The plates are all the same. It's a universal fit plate because of all the through holes. Robert, can you hold yours up? I don't have a screwdriver with me. I can't. Oops. Bring my camera back right to me. Hang on. Switching my camera back to me.
These go into the 4U chassis, right? These go in and I think 4 of them fit in a 4U.
Yeah, I can. It's a little bit better to do 3 of them, but 4 do fit. They go in horizontally and then front to back. On each end are tensioners to lock it into place against the side wall of the chassis of the rack. What is the word I'm looking for? Well, I guess server chassis. And then the plates that you were holding up slide in, drop in vertically. So you can pull a node in and out, take it in and out of service. Yeah, there you go. Just like that. You just grab those and pop it right back in place, and it snaps in. It's got a little bit of tension on it, and you just essentially squeeze the clips to pull them up and out, kind of like a blade server. So he custom designed the overall holder that you have in your hand, as well as the plates to slide in and the mounting holes in order to put the various boards on. So we can pretty much put any board into the server chassis. It's absolutely ingenious. It's open source also. Rachel, I think we have a link for the GitHub for it. So we'll get to that in 1 second. But point being is, I can then load up. Remember, I said I took a regular off-the-shelf 4U server chassis and gutted it. Once it's empty, it's just an open area, open rectangle, and I can put those in and then bring in the power and Ethernet.
Yeah, so like David mentioned, these are open source. Now, right now, they're being hosted on Gabriel's GitHub. We're going to try to get them on a more long-term GitHub, but we can share the link right now. So, Bruno, like you mentioned right here, wow, he designed what I've been trying to do for so long, the agnostic SBC rack. Kudos. Yes, Gabriel did design the agnostic SBC rack for a 4U chassis and 4U because the 2U, the 3U, the 4U get wider, right? Taller, I should say. And so this does fit in a 4U. I don't think it'll fit in a 3U, right, David? Or maybe it will. I think we went with 4U.
Will, but I like to bring the Ethernet cabling across the top and the power across the bottom. And so it's a little bit tight in a 3U, only because when you go to bend the Ethernet it depends on, well, sort of depends on where the board places the Ethernet port. But it's a little too tight. And I like having the additional height of the 4U for airflow, because then I can put 120 millimeter fans up at the front and blow, it's in a data center. It has a cold aisle and a hot aisle. Again, if you're familiar with how a data center is laid out, you have rows and rows and rows and rows of the server racks. So the cold air comes from the bottom, from the floorboards. It's a raised floor data center. So there's, a crawl space about yay high under the floor. Anyways, the cold air comes in there, is blown up the front of the chassis, and then exhausted out the back. So that's the hot aisle, and that hot air is then sucked up out and sent to the chillers. So anyways, long story short, I kind of prefer the 4U just for thermals and cable management. You could get away with a 3U if you really needed to, though.
Nice. Yes. And real quick, just to kind of add a little bit to that. Again, as I mentioned, you can literally go download these STL files right now and build it yourself, right? So this is kind of like the cool thing. It's not just about, hey, you have to use mini nodes and ARM subsidized server racks. If you want to go build your own rack and put it in your own data center, you can go do it yourself. We're providing you with the STL files. All you have to do is go download them and get your 3D printer up and running. Yep. So David, since we've been talking all about this, why don't I bring up the pictures? I've been like trying to send them to myself here. So let me see. I have my Discord here. Uh-oh, my camera froze. I can do this. I can fix it. I'm gonna fix it. I'm gonna fix it now. I've faced this problem before. Can I fix it?
Mine has, mine does that too.
I think I can fix it.
We can hear you. We know what you look like.
Oh no, I gotta fix it. I want to fix it, David. Give me a sec.
Oh, that's all right. Take your time.
But while we do it, we can bring in the the screen share here.
Yeah, there we go.
So, bring this
construction. Up. Yeah, look at all those pies. Wow, that's a lot of pies.
So, David, why don't you talk about them while I fix my camera?
Yeah, so that is, we had 50 Raspberry Pis to start with. You can see here I have them all prepped and ready to go into the chassis. I actually think that we're down to 47 of them, to be perfectly honest. Neither confirm nor deny. But so those are the Pis as they were getting placed into those racks. Down at the bottom, I actually see that might be Jets. No, those might be solid runs down at the bottom there. Tough to say. Next up there, that red one is a solid run device. And I specifically wanted these in the rack for a couple of reasons. And we can talk through a little bit of this as well. Okay, number one, solid run is an excellent ecosystem partner. They do a lot of work for the community and in the community. I don't know if John is watching, but if so, hello. And no, your camera's not back yet. Oh, there's your face. We see your face. But Solid Run, this particular unit is based on an NXP IMX8 SoC. And NXP also is a very important player in the push for standards and open, the system ready, IR, ES, SR. I'm forgetting probably two of them, but NXP does a lot of work ensuring that their firmware meets those standards. So I absolutely wanted to have them in and represented. If you want to go to the next one, there is a 96 boards device. You can see how it's getting racked. I actually have one of those. I pulled that out from the rack. This is a 96 boards Ultra 96. This one was specifically chosen, again, because 96 boards is incredibly important to the overall ARM compute ecosystem. They have done a lot of work over the years making hardware available. This one happens to have an FPGA on it. This is a Xilinx part. So I thought it would be neat for individual developers out in the world who might want to start dabbling with a little bit of FPGA experimentation. Now, I am not an FPGA expert. I don't know how to use an FPGA, but I thought it would be cool to make it available. So again, just like that solid run part, I wanted to represent both the vendor and the SoC manufacturer. So that's how that one got in. Hey, you're back.
I went to the old school Logitech camera here.
Yeah,
try to get fancy. It uses up so much bandwidth that every time I open up a new program, what happens is like it freezes up the camera for some reason. The USB hub. Cool. So I'm back. Yeah.
Okay. What do we have next? Okay. There is the back. That's when it was still empty. That's the back of the rack, actually, where the power strips are. There is a chassis. This is an early prototype still where the power brick was being used for some testing on, those might be the solid runs up at the front there. And there's no Ethernet in there either yet at that point. So that's a construction shot. Oh yeah. Oh, we're going in reverse order. Yeah. This is chronologically backwards.
Well, these look
maybe not.
These
maybe
looked.
not.
Yeah, I think they were just.
Hold on. You mixed and matched. That's okay. There's the first. There's the shell of it emptied out with just the racks in, and you can see how they just use tension to press against the walls of the chassis. Okay. There's some, nothing
patch
wired
panels.
Yet. Yeah, nothing wired yet on the switches there. Here's the first Ethernet coming in. Those are Jetsons in that first row.
Now they're getting hooked up. Here's the front. Here's a front
There's
view
the front
of the
of them.
3 4Us.
Yep, there's the 3 chassis there. I don't know in that picture if they're empty or filled at that point. These are the solid runs here, and these are actually PoE, so that's kind of nice. Just bring it right off the switch. There's one open. That's a little bit further along. That's about half of the Ethernet cabling. Yeah, there's an early one.
And there's
the cartridges, the slots to go in. Yeah, so pretty neat, pretty cool stuff.
So one of the cool things here, right? And we got to actually use this system for ARM Dev Summit. Yeah. And during ARM Dev Summit, there was a Facebook Magma workshop. I don't know who got to experience this workshop, but David, you were pivotal in this, right? And, being able to use this program was also very pivotal. So in the past, what we've done, and I'm pretty sure a lot of people out there liked it, but who knows how many of these Raspberry Pis or boards just ended up in someone's desk drawer, right? And then never got used again or whatever. The point being is that this type of system is ideal for workshops, remote workshops, because now what we can do is we can host a workshop with 50 people and we can literally provision these out to the attendees of the workshop for the time of the workshop. And then no need to ship anything, no need to get anything shipped back, no waste of hardware. And of course, you just get access to it, which was really nice. And we can, of course, flash the devices with what needs to be flashed for the workshop. So, definitely a step forward when it comes to workshops.
That Dev Summit that session was like you said, a Magma, which is an open source project from Facebook, a 5G gateway project. And the attendees, in the past, you would have had to ship, there were 50, so you would have had to have shipped 50 Raspberry Pis, 50 power supplies, SD cards. I'm trying to think if there was any additional hardware required or not. I don't think so. Logistics and cost, of course, that go along with it. But for Dev Summit, it worked out great. We pre-provisioned the devices. I think they needed Ubuntu 20.04 or something. Not a big deal. Plug them in, assign an IP address, and then all of the workshop participants could simply access it remotely. And I think we left them running for about a week or so. And then we said in advance, you'll have access for a week to get through. The workshop was delivered live. It was ARM and another vendor. And, folks went through it, but then we kind of left it up and running for a little while so they could continue to test and iterate and then tore it down. It's awesome.
Excellent. Yeah, I mean, it was a lot of fun. I know that towards the end there, we were in crunch time getting everything set up. And it's like, oh man, are we going to have all of this ready in time? And then, the engineers who were putting the workshop together, we had to give them access to it, a month ahead of time or 2 months ahead of time so that they could prove that it even works for the attendees. But it was nice. So David, let's talk about the places where people can go to check this out. So I'm going to share my screen one more time here. I'm going to share another screen this time. Window. And here we are. What do you know? Mini Nodes logo. It's beautiful.
Yeah, look at that.
So we recently launched this page. In fact, it was just launched on Tuesday, I think. I created the page, and I'm gonna kind of go through the works here, right? So you can go to developer.arm.com/solutions/infrastructure and /works-on-arm. This is a preview of all the different offerings that the Works on ARM program has. As I mentioned at the beginning of this live stream, you already had access to AWS, Equinix Metal, Oracle, and OSU OSL. So if you want to go get access to some of these beefy servers, there are lots of places to go. In fact, we had a person from Oracle, a representative from Oracle, join us not too many months ago, talking about their free tier. And this is where you would go to access their free tier. You can go onto the Oracle page, go view, request resources for your project, and then boom, there you land on a place to go request resources. So we wanted to do something very similar. Here you are with Equinix Metal, same thing, go there. Now, with this particular one, the new one here that we're talking about, with mini nodes. So if you want to request access, what we're going to do here is we've created an open source repository. Now, there's no code or anything on here. Hopefully, what we can do in the coming weeks or month is to get those STL files for all of this really cool 3D printed stuff. We might be able to get it added in here because it is kind of like a part of it. Again, we just need to kind of get that process rolling to get it all into this repository. But the process here is very similar to the one that you may have experienced if you did with Equinix Metal. So in order to request hardware, all you have to do is go to this repository, works on ARM.org, GitHub, works on ARM.org, mini nodes -ARM-edge. There's instructions here on what to do, but basically you just open an issue. You open an issue, log in. I was going to ask for my 2FA. Damn.
Yeah.
All right. Well, you know what? Either way, you open up an issue, and then you tell us what the project is that you're building and how long you need access to the hardware for. It's really that easy. So, David will be the one working alongside myself, vetting these projects and then provisioning this hardware out to people. What we will be adding here as well is a list of the different types of boards that are available. So you got to tell us what project you're going to be doing, what board or boards you need, and then how long you need them for. And then we will provision them out to you and you'll have access to them for that amount of time. If you need to renew that time, you can always reach out to us and let us know that you want to renew that time. David, I want to address some questions here in the chat because I've kind of let them run a bit. So let's see. I'm going to scroll up here.
go to the top. Just take them right down in order.
Yeah, I'm going up to the top. So number one is...
Yeah.
Oh, sorry. Go ahead.
I was just going to say real quick, I'll add to this. Like you said, we just got the repo up and running. I can see last commit was a couple days ago. I'll add to the top of this within the next day or two, a little table that kind of shows the, I guess you could call it inventory of what's in the cluster and what's available. So, at least you can eyeball right away what we have. But yeah, we need to say a quick thank you to Ed and Packet, now Equinix Metal, because we're totally using the template that he pioneered.
Yes, we took that from him.
Yes.
So let's see. If anyone knows my password at the exact moment I put that 2FA in. Sorry, there you go. All right, so I put in the stuff here. So now
Gotcha.
you would open up an item here.
Yeah.
What were we talking about right now? Oh, the questions.
We were going to take a look at questions.
Okay, so questions here. The first one is, and this goes a while back, David, do you guys use Pico clusters?
No, we do not. Pico Clusters are a really cool product by an organization by the same name that make essentially little miniature tabletop plexiglass or I can't think of the word for it, but the clear plastic with all the guts of what would be a miniature cloud, like a switch and 5 or 10 boards in it. It is intended to sit on your desk, single power supply, single Ethernet. They're cool looking, but we're in a data center. It won't work here.
All righty. Thank you for answering that. The next question is also from Arjit. ARM software developers, can community people contribute stuff to this too, like sharing hardware? So if I understand this question correctly, you're asking if you have hardware that you've custom designed, can you send them to us and host them in this center? I want to say yes. I don't see why not, as long as it fits the form factor. And
yeah, I mean,
the for you.
I'd say the same. I mean, it's not something I had totally thought about or envisioned, but I don't see any issue with it either, so long as I can mount it, standard power, standard Ethernet. Shouldn't be a problem. Yep.
Yeah, and I mean also, these universal plates.
Yeah.
We also can get them redesigned to add more board form factors to it.
Yep.
Right. So it's not very hard to do that. The person who does this, Gabriel Peterson, he can help us get those added in. So that's another thing, right?
That's the beauty of 3D printing. You can custom fabricate anything that you need. You don't have to go to a design shop.
Next question is from Bruno. Fantastic. Can we enroll those devices into Balena Cloud?
I haven't thought about how to do that. As it stands, they are all provisioned with whatever operating system the vendor supports. So for example, Solid Run builds images. Obviously, when you purchase a board, you go and download the SD card image, flash the SD card, and plug it in. Because some of these devices are, that's the difference in a lot of what I was talking about earlier with, standards and boot processes and things like that. Jetson Nanos, for example, you have to use the NVIDIA Jetpack distribution of Ubuntu if you want all of the features to work. So as it stands, each vendor provides an image for a board. You flash the SD card and power on. And that's what I've gone with for the moment. If somebody had some unique need for a specific OS, we could do that, but the Pis run Raspbian, the Jetsons run Jetpack, 96 board, Xilinx builds an image for the Ultra 96 and so on and so forth. So no, they're not a Balena device. They are a whatever the vendor provides at the moment device.
There are other questions that are after that, but Bruno has a follow-up here. How do you flash remotely? Are they running Balena OS?
You do not.
So you'd have to go into the center, right? Yeah.
Exactly. Now, I will say another of our wonderful ARM innovators, and I saw a few of these questions roll by, so this is going to knock out about 3 of them in one fell swoop. Another of our fantastic ARM innovators that does a lot of work in the ARM compute ecosystem, Andre from Vmware. They have a Fling. A Fling is a non-supported product, but it is a test. It is their beta laboratory, and they have a Fling for ESXi that runs on ARM. And a couple of devices can, in fact, run that as the underlying base OS, and then you provision a VM on top of it. So with ESXi and an ESXi server, you can then build a cloud. Let's call it the 50 Raspberry Pis. We could put all 50 in, connect it to the vCenter server. From vCenter, provision out 50 VMs onto those Pis and enable, manipulate, manage, reboot, et cetera, through there. So there is no vSphere server, mostly because they are extremely expensive. But, maybe if we ask real nice. So no, they are not running the ESXi hypervisor. They're just running Raspbian. But it is something that I had kind of thought about. So we might have to explore that path in the future.
Yeah, and that's the next question Bruno had in the lineup is, could we try ESXi Fling with some of the machines? So I believe you answered that. Now we have the last one here. It's not a question, it's a comment. David lowered the barrier to virtual autonomous racing. It wouldn't be Innovation Coffee call if David W. didn't come in with some form of autonomous vehicle comments. Now you can run Donkey Car and you don't even need your own Pi. Yeah, in fact, what you could do is we could just put a little racetrack inside of the 4U rack.
Running around inside the data center. It's got all kinds of challenges and things to run into in there.
Very cool.
Yeah, that's a shameless plug. I was hacking on the donkey car repositories the other day. Those are fun. I'll grab the link and put it into chat if anybody wants it.
Excellent. So David, I think this kind of like wraps most of everything up, and we don't have to go to the top of the hour if we don't have to. So I guess the last thing I want to say, and then we'll hand it over to you for a shameless plug or any last words. But we will be releasing a blog that basically summarizes most of what we talked about today. Of course, the origin story of this community hardware program, various resources and links that we discussed. We'll of course provide everything as well in the description of this video for everyone watching later. And yeah, so keep an eye out for that blog. I will share it in the ARM software developers Discord server, which is now rotating down on the bottom of this screen here. If you're not already in that server, join. So I'll be sharing it there. And yeah, it's been a pleasure, David, honestly, working with you. Keep in mind that this community hardware program, I was going to do an unboxing here, I think just showing the box. Oh yeah, I got this.
There it is.
Showing the box alone. This is the kind of stuff you're going to see inside of this lab. Again, it's not just Raspberry Pis. It's not just NVIDIA Jetson Nanos. Not that those aren't awesome boards, but we're going to be providing you with some early access and difficult to access type hardware. Yeah, David, it's been a pleasure working with you on this. I'm very excited to finally roll it out and see if anyone out there needs access to this kind of stuff and see what we can provide developers with.
Yeah, definitely. No, I agree. You've had the Works on ARM big server options for a number of years, and there are teams out there that absolutely need that. TensorFlow comes to mind. If you're a TensorFlow maintainer, you absolutely need all of the horsepower that you can possibly get a hold of. And Equinix has you covered, or the Oracle Cloud has you covered. Fantastic. But, there's a whole nother world of people that they don't need that. They do not need 128 cores of raw compute power. But what they do want is some of these more esoteric devices, like that one that you just held up. You can't get that. We as a community and developers need to have ARM helping and nurturing, and you have access to it. But, regular people out there don't really have that. So that's going to be really cool to bring that and make that available to community developers. So I'm looking forward to some of those more random, crazy devices.
Yeah, I should add, actually, if there are boards out there that you all think should be added into this system, let us know. We're always listening. Again, drop us a line, drop me a line. I'm Fixer in the Discord server. Drop me a line. Point me to a link to a board that you want in this data center, and I will buy it. And we'll put it in there, of course, if it's ARM.
And cost is reasonable. I know there's some are. I've seen some, in the multiple thousands of dollars priced.
I don't want to put a limit on the price tag. If it's necessary and we can do it, we'll do our best to make sure we can. So we'll try our best. We want to make sure developers have all the tools they need. It's a big push that we're trying to do, making sure that you as developers out there have everything you need to develop, test, build on ARM. And so this is our commitment here. And thank you so much to David for helping make this possible. So David, sorry, any last words now?
No, we covered it. That's it. We're good.
We covered it, didn't we? All right, cool. So I'm going to close this out then. Look into the camera here. Thank you, everyone, for joining us for ARM's Innovation Coffee here, the new year, first episode of 2022. Happy New Year to everyone. If you enjoyed this video, don't forget to hit that like button. Smash that like button. Hit it real hard.
It's right down there. Get it.
Yeah, right down there. Smash that like button. We do this every week. We have a bunch of very, very fun episodes planned for you all for the next coming months. We're pretty much booked out until the end of February for that matter.
Wow.
So, there's lots of fun stuff going on every Thursday, 5 p.m. UTC. If you are interested in being a guest on this show, you can also reach me again on the Discord server, and we can get you on here. Follow us, ARM Software Developers on YouTube, ARM Software Dev on Twitter. It's been a pleasure, everyone. Thank you so much for your time. I hope you have a wonderful 2022. David, thank you for being our guest today. Mini Nodes, amazing company, amazing ARM innovator. We'll see you soon. Everyone have a wonderful day.